Hello, everybody. I'm John Sheehan. I'm an architect on the Windows team, and with me is Kieran Mockford, who's an architect in the developer division at Microsoft. Today, we're going to talk about developing a Windows Store app. And this is a 300-level course, so as you'd expect, we're going to spend a little bit of time talking the slides, and we're going to spend most of our time in Visual Studio writing code. So, to begin, I need to talk a little bit about the Windows 8 platform and the changes that we made to it for Windows Store apps. And whenever we talk about architecture, we usually start at the bottom. And for Windows, the bottom is the kernel. The kernel for Windows 8 has had a lot of changes done to it, mostly focusing around performance, focusing on memory usage, focusing on security. And so Windows 8 is the best Windows we've ever shipped. If you take a Windows 7 machine and you upgrade it to 8, you should see that you'll get better performance, you'll get lower memory usage, your app should launch and run faster, and it overall should be a much better experience. But today we're not talking about the existing apps that you run on Windows 7. We're going to talk about these new store apps. And for that, we need to start by looking at WinRT. So what's WinRT? At the beginning of Windows 8, when we started planning, we realized that the developer experience that we've been providing for Windows for years was kind of dated. If you wanted to write just a native Windows app, you'd program to Win32, which was a C-styling program API that originated in the 80s and 90s. You would use patterns like first call a function, pass it a null pointer, pass it pointer to a D word. We'd return you the size and an error saying that the call failed. You'd allocate the buffer, you'd remake the same call again, and this time hopefully it would succeed. And you do all these machinations, and all you really wanted to do was get a piece of information. And so we decided that we really needed to rethink the way that developers built Windows apps. And so we came up with WinRT. And WinRT is a new modern API surface that you use for building your Windows Store apps. There are tons of APIs in WinRT, and we'll talk more about those as we go through this talk. But the key thing to realize with WinRT is we chose that not to just choose a single programming language like C. We decided instead to build a system that can support all the programming languages that we wanted to. So if you're a C++ developer, great, you'll program directly to WinRT. If you build C# or VB apps, you'll still program to WinRT. And new for Windows 8, if you're a JavaScript developer and you want to build a native Windows app using JavaScript, great, you can, and you still program to Windows RT or WinRT. And so we're really excited, and we think that the developer experience makes developing Windows Store apps fun. And I tell you, I write them almost every day, and I have to say it is definitely a lot more fun to program WinRT than Win32. On top of the base API surface, we have the presentation layer. And this is really the technologies that you're going to use for building your UI and your logic. And something new for Windows 8 is we finally decided to modernize the presentation technology for C++. Up until now, you've basically been stuck writing MFC apps or trying to choose some third-party presentation technology for C++. Starting with Windows 8, you can actually build a XAML app writing native C++. And when I say XAML, I don't mean the XAML that you've seen before, which was a managed technology. We rebuilt XAML from the ground up to be completely native. So if you choose C++ and you choose to use XAML as your presentation layer, you will get native performance. You won't have any managed code in your process at all. And if you want really, really high performance C++, like you're writing a game or something, you can always choose something even lower in the stack, like DirectX. XAML and C# obviously still work great together, just like they always have. And if you decide you're a JavaScript programmer and you want to write your app in JavaScript, the obvious choice for your presentation is HTML and CSS. This is the Windows Store app model. Now, we still obviously have desktop apps. And as I started with, they're still great. As a matter of fact, they'll be better than they were before. But we're not going to be talking about those today, so this will really be the last time that I talk about desktop apps. But be rest assured, if you take your Windows 7 device and you upgrade it to Windows 8, you should expect that all those desktop apps will still continue to run. So, what are the steps to creating a Windows Store app? I mean, first and foremost, it's obviously your app. So it's about your code. If you're building a mail app, it's going to be the code for fetching the mail and displaying it. If it's a calendar app, it's going to be displaying the user's calendar. If it's a weather app, it's going to be the app that goes and fetches the weather. So obviously, starts with your app. But there's a lot more to it to that. The next thing, once you've actually written your app and written your code, you're going to want to publish it to the store. And you're going to want your app to have a unique personality to it. It's going to have a tile. That tile is going to be on the store. When the user installs their app, they're going to see the same tile on their start screen. When they launch the app, they're going to see the splash screen. And I assume that when you build all those things, you'll make sure that all those things fit with the personality of your app overall. You have full control over things like your tile. They can be full bleed images. You have complete control over what you want the personality of your app to be. At that point, you might think that you're done. You have an app, it has your personality, and the user can use it. But you're really not. User expectations have gone up for Windows 8. Nowadays, people expect things like live tiles. Like if I have a weather app, I don't even want to have to launch your app most of the time because I'm usually interested in what the weather's like right now and maybe for the next hour or two. And so I, as a user now, would expect it to have a live tile, and if your app didn't, I might uninstall it and try to use someone else's app. I expect you to integrate in the system. If I go to search, every user in Windows will go to the same place to search each time, and they'll expect to see your app there if you support search. I'll also have expectations around things like security and trustworthiness. We had this idea at the beginning of Windows 8 that we really wanted to make sure we raised the bar in user confidence for applications. So we wanted users to be able to freely try your apps because, in all honesty, we want you to make money. We really do. And it's really hard to make money if someone's afraid to even try your app. If the user has to make a value judgment about whether they're willing to install your app and whether they think it might be trustworthy, then we've already failed. And so we wanted to make sure that the apps were completely trustworthy for users so that they could just try them out and use them, and if they don't like it, they can uninstall it and feel safe and feel confident that their system will be okay. So, enough talking. Let's get to code. Kieran?
Thanks, John. So it is my privilege today to be the code monkey for a bit. We're going to write two apps today. I'm going to be responsible for one of them, and then I shall pass the monkey to John. But the topic of weather, John's already mentioned weather, and I don't know whether you noticed when you drove or when you arrived at the facility this morning here, there was lots of weather out there. And there's certainly lots of weather going on in New York at the moment. So I'm going to create a weather app to begin with. And it's interesting because it was the very first app that I wrote way back for Windows 8. Now I have a little service which is sitting up in the cloud in Azure that if I just hit it with a URL, it'll return me, as one would expect, a nice big blob of JSON. And in the JSON is the weather forecast for the next few days and also within today, the next few hours. So this is what we're going to consume in the app, and we're going to present it in interesting ways. So I'm going to use Visual Studio to do that. This version of Visual Studio happens to be the Ultimate Edition. All of the code that I'm writing today will work fine in the Express for Windows Edition as well. So I created a new project. Now John has talked about the language projections for WinRT. They're all here in Visual Studio. The first app, we're going to use JavaScript. And I'm just going to start with a blank application. And I'm going to call it Build Weather.
That's a creative name.
Or not. I will call it Build Weather 100. Or not. I will call Build Weather 200. I might have been practicing. Okay. We're almost done. No, we're not. The first thing I need to do is get hold of that data. Now, there are some parts of this app, because it's in JavaScript and HTML, that are really bog standard JavaScript and HTML. And I'm going to breeze over those relatively quickly so that we can focus a little bit more on the things that make it more uniquely Windows. So when you find me feverishly typing and John is doing a lot of talking, you'll know I'm in those bits where it's just bog standard JavaScript and HTML.
I'll do my best.
Great. Let's begin. So I'm going to create a new source file to go and get the data.
And so, as Kira was talking about, this is very much just standard JavaScript, standard HTML, CSS. All the code that you have today, the toolkits that you use today, they all continue to work because we just left it as JavaScript. There's some additional functionality that we have, like the Windows library for JavaScript, which is our own toolkit for making it easier to build apps, and has some nice simple functionality for things like defining a namespace. Right? A namespace for JavaScript is really just kind of like a static class, and it's a way for you to just keep from polluting the global namespace and organizing your functionality, because that's not something JavaScript really has natively. And just about every toolkit you've ever seen has one of these, so we have the same stuff. There are other things about WinJS that are of note. One is that it has the concept of a promise. Now, promises are very, very standard. It's a very standard concept that all of the toolkits out there have. It's being standardized by W3C eventually. And so when we started looking at the things that made building apps challenging, one of those things was asynchronous operations. And what a promise does is basically makes async programming much, much more straightforward. So here, he's using a helper that we have, which is XHR. It's just a simple wraparound XML HTTP request. But instead, what it does is it turns the results into a promise. And with promises, you can then chain them together. And so that's what he's done here. He's chained the promise together. And now he can fetch the information from the web. He doesn't block the UI thread or anything. It's asynchronous. When it's done, then his code will run at the right time, and it'll go ahead and take the information and continue. And he actually returns that promise out of the function so that he can actually even chain it up from the caller. And so the caller can get the promise back, and then they can go ahead and chain it up to other ones and so on and so forth. And so if you've used any of the other common toolkits out there, you would have seen exactly this same pattern. How's the typing going, Kieran?
Keep up. All right. Okay, here we go.
All right. So now you've actually gone and fetched it. We've hit a breakpoint. Interesting. And what's in there?
Okay. So it's gone out to the Azure Web Service, brought the JSON back, deserialized it, and presenting it to me, and I'm just looking at it in the debugger. There are a couple of levels in the data structure that's come back. Here's sort of general information about the weather and the origin, the default location, the current weather, as in what it's like out there right now, except it's in London, so it's not out there, it's over there, but you probably wouldn't know the difference. And then I've got a forecast into the future about 10 days, and then also some hours into the future as well. So I've got the data, and now I need to put it into some presentation, because if I let this app run, it really isn't tremendously interesting right now. Okay, so let's go and do some presenting of that. Now, of course, it's HTML and JavaScript, so the presentation is in HTML. Now, because again, this is relatively standard HTML, I'm going to go relatively quickly over it, and I shall make use of the wonderful feature in Visual Studio called the Toolbox. And the Toolbox has some code that I prepared earlier so that I don't bore you with my HTML typing skills. And again, John, I'm sure, will want to embellish while I'm doing that.
No, good. Go for it.
Thank you. Okay, so this is a place for the weather summary to get put, and a video, which we'll come back to in a little while. And in part of WinJS is the ability to take data, bind to an HTML template, and then put that template basically into the HTML DOM to provide user interface. So I'm going to add a template. Now, there's quite a bit of code that was pasted in here, but if you look carefully, it's just completely standard HTML. I've got divs, I've got headers, I've got a paragraph here for some spacing, except there is a standards-based data dash attribute that's been added to the element, and this tells WinJS that this is a binding template. And that'll do two things. One, it'll cause WinJS to instantiate a template object for me, and it'll also make sure that it doesn't appear in its template form in my DOM. Otherwise, I'll have random templates appearing on my screen. So it'll make sure that they're hidden. Now, also as part of that template binding, obviously there is the need to assign data to elements. So you think about, I just deserialized the weather object, and in this span I want to put the temperature. So in the text content, which is a relatively recent standard property on DOM elements, and my PC is alive with activity, you can then I take weather.current.temperature and assign it to text content. And the same for the rest of them. So now I have the template in my DOM. I need to get hold of it in my code. So here I am in the function. I've got the data from the web service. I want to get hold of that template and data bind it. So I've just pasted in some query selectors, just reaching into the DOM and grabbing hold of the elements. This is slightly different to what you'd normally expect to see in reaching into the DOM and getting an element. I'm asking for the Win control. So this is the object that I mentioned that Win.js has instantiated for me to represent this template. And the summary div is just a place for me to put the resulting HTML into. So then once I've got the template, I can then say template.render, and I want to render the weather, and I want to put the results in the summary div. And in a teeny tiny font, it's 46 degrees in England, and it actually appears to be fair. Wow. Okay. HTML and CSS is our display technology, so in order to prettify that, I just need some CSS.
So you're going to type all the CSS for us?
Yeah, no. Because it is just completely normal CSS. Margins, height, padding, exactly what you'd expect to see. Run that again. Now it's beginning to look more like I want it to, and all I did was add some CSS and a little attribution to say where the weather information is actually coming from. It's actually coming from the Bing weather service that I'm reprojecting. Okay. Now that's okay for the weather now, but I've also got those intraday forecasts, so for the next few hours into the future. I'd like to be able to display those. Now, one of the characteristic pieces of user interface, of course, in Windows 8 is what we call the list view or the grid view, depending on the technology you're using, and it's the tile-based UI with the templated elements in each one. So I'm going to go ahead and create a tile-based UI that will show the intraday forecast going forward into the future. So because I'm binding a list, there's a couple of things that I need to do. First, I need a list to bind to, and I'll do that in, I'll extend the data namespace that we have.
And so again, this is just that namespace that you defined before. You can add new elements to it, and one of them is going to be your list, or your binding for your list.
And you'll recall from the data structure that the first day of the forecast has got the intraday element on it. Iterate over that, get each hour out. And because this is a namespace and not an object, I need to fully qualify the name of the data structure and JavaScript standard syntax. I'm pushing elements into the array. And just for completeness, because it will matter later, if there happens to be any data in the array before we start, I want to remove everything in it. And of course I use splice to do that.
Of course.
Of course.
Makes sense.
Great. Let's just make sure that still compiles, as they say, by running the app. Now I need, so I have the data in a binding list that Win.js has provided for me. I need a template that will represent each of the items in my user interface. So again, just need a standard piece of HTML. And again, it's a template control. And it has the same binding elements that I had before. This time, each one of these templates is going to bind against each hour in the list that I passed in. Okay, but because I'm dealing with user interface, I'm going to open this project in Expression Blend. Expression Blend now supports HTML applications for Windows 8, and it'll launch the design surface and instantiate my application right there. And you'll notice that it's actually showing my application running. The app is actually running at this point. It's gone to the web service, it's bound, it's done all the data, but I can actually interact with it on the design surface, and I can see not only the live DOM on the right-hand side following my mouse clicks, but it's also following the data template that I use to actually data bind this UI. So Blend is really giving me a rich interactive mechanism that HTML developers absolutely love, that fast iterative approach. Great. Okay, so I've got the static piece. Now I need to go and get that all-important list view. Now, if I go to the Assets panel, I can see a toolbox full of all the controls. All of the HTML controls are here, but some of the common ones are pulled out into a separate group. So I want the list view. I will drag that on, and you can see that it's added it to my DOM down here. I will just give it the class that I gave in the CSS earlier. There we go. Now I will assign the data source that we defined, the hourly list, and I just type that into the item data source, and then need the data source member, and you can see that's bound, but not very pretty, because I haven't assigned the template yet. If I just assign the template, then again, Blend is interactive, it's doing it iteratively, it's live. But there's a problem because my images are not showing up properly. So I can click on any of these bound images, and on the right-hand side here, you can see the image source is set to images tile_26. And because it's /, it's relative to my package on this machine. Because Windows apps, obviously, they run locally. They're not served from a web server. So that / is relative to the root of my package. So I need to grab those images and throw them into my package, which I can do from the project right here. They happen to be in my SkyDrive.
Of course.
Of course. I'm all in on SkyDrive. But I don't get a free 100 gigabytes of space.
Yeah. Some of us have to pay for that.
Great. So now my clouds are all there. And I can switch Blend into interactive mode. The screen goes full size. And now I can actually interact with the application.
There you go. There's the rain. I was going to say, we have yet to ever see anything other than rain every hour of every day.
There it is. Okay. Great. So my bound user interface is now complete. I save everything there, switch back to Visual Studio, and it will reload the changes that I just made. Now, I mentioned earlier, and the Hawkeye amongst you will notice that I put this video element in here. So I've prepared a number of background videos for the app to really give it that beautiful character. So the first thing I'm going to do is go into the show weather function and add in the code. Again, it's completely standard DOM manipulation, because that video element is an HTML5 video element, and it supports an MP4, which is what I happen to have. Now, if I run this now, it won't work because I don't have the videos actually in my package in the same way as I didn't have the images in there. So let me just put those in. And we will run. And of course, it's nighttime in England.
Great. So,
and we are in England.
Give or take. You get the shirt.
Nice shirt. Love it.
Thanks. I love the accent. It gives credibility to this whole talk.
Does it? Great. Anytime I can be useful, you let me know.
Yes, seriously. So, all right. So now we have an app, and it's all the code, and it looks like a weather app, but
it hasn't got much character.
Right. So what does it look like to Windows?
Yeah, let's have a look. So here's the tile for this app. It's kind of boring. The splash screen, as you noticed, was sort of gray. So let's fix that up. What I need to do is the Visual Studio template has a number of logos that it supplies by default, and they're meant to be deliberately dull so that you're incented to go and change them. So I have some that I have to try and spice things up a bit. Again, it's in SkyDrive. And I've pre-prepared the image. Actually, I didn't do these. A designer did these about 2 years ago, so they're very pretty. Otherwise, they would look pretty nasty if I did them. So I'm just going to put those in, and they've been added to my project and replaced the ones that were already there. And now I need to do a couple more things. So it's added a wide logo tile as well. By default, the Visual Studio templates don't have the wide logo. So I need to go into the file that describes this application to Windows, called the Apex Manifest. And in here, I can add in the fact that I now have a wide tile logo. And also, I can change things like whether text will appear, the name of my app will appear on the tile. I have the name of my app actually on the bitmaps, on the PNGs for the tile, so I don't need that. So I just switch it to show the name on no logos. And the background colors, I want to use that same dark blue color that I used for the tiles within the app. And of course we know that that's 0000FF.
Obviously.
Great. Okay, so that should now be the character of my app. I have a splash screen, and when I go back to the start screen, there's my weather app with its small tile. And if I right mouse button on that, I can now expand it to be larger, and there's my large tile. So now my app has character.
Great. So you're done?
Yeah, that tile's pretty static. It's not alive.
Yeah, as I said, I as a user would expect that to be a live tile.
Yeah. Okay, let's make it live. Okay, so there are a number of ways in which you can do live tiles, and I'm going to pick one particular mechanism which is kind of useful for things like weather apps.
Yeah. So as Kieran said, we have several different ways, and depending upon your scenario, you can choose different things or different ways of creating a live tile. Now, what Kieran's doing here is he has a service, and that service has the information for the live tile and the information on it. And so all he's going to do is tell Windows to periodically go and check that service, and that service will provide the latest information, and Windows will automatically update the tile for you. He's picking it to be hourly, and that seems like reasonable for weather. Other kinds of live tiles are much more user-specific, and they're much more time-sensitive. So if you were building one of those mail apps, and you wanted to make sure that every time the user received a mail, that their tile got updated with all of the mail, then you could. And for that, we have something called Windows Notification Services for building those kind of live tiles.
Great. So the URL that I'm going to ask Windows to pull on periodically for me is going to return an XML document that looks a lot like this one. This is actually the one that's coming from the default tile service right now. And it's very, very simple. It's got an image reference, which is obviously a picture of one of the cloud formations, and then a small amount of text just to give us a little bit more information. So this is the URL that I'm going to paste into the code to say I want you to pull on this live tile. The API also supports a location argument, so that I can add on weather location name from the data that I bound. And I want to pull on that every hour, which I had in the recur property there. Okay, let's run that. Go back to the start screen, and there I have a live tile. So that will now be pinged every hour-ish, give or take 15 minutes, and if your system happens to be on, and it'll go and pull it. But there are other times when it'll pull on that as well. Obviously, when you start your machine, you first go back to the start screen. Another way that you can get the tile to deliberately pull is if you right mouse button on it and say turn the live tile off, and then turn the live tile on, it'll go and pull on it again. Just so that's a good developer tip if you're testing your service. Okay, so now I have a live tile for London.
But we're not in London.
No, it's definitely not in London. I wonder where we are. Windows can tell us where we are, right?
Yes, it can. So Windows has, as we talked about earlier, tons and tons of different APIs for all different kinds of scenarios. One of those is our geolocation APIs. And so you can use our geolocator object to ask Windows to tell you where the user is. Now, if the device you're on has a GPS, then obviously you'll get a very accurate representation of where the user is. Some devices like laptops, since they don't have GPS, we can use other techniques like using the IP address. Now, the funny thing about this is that I've used this API tons of times. We've done this demo in many different places, and the results are always very close. Like, it tells you the town you're in, but it might not know necessarily what building you're in. Interestingly enough, every time we come to one of these big conferences, the network's always different. So we were quite surprised to find out where we were today, which is,
in an exception.
An exception. All right, you're fired.
Thank you.
All right, what did you do wrong?
Well, actually, I didn't do anything wrong. Oh dear, this is so cheesy. The problem was I used the geolocation API without specifying that my app is going to use the geolocation API. So this is part of that confidence that John talked about earlier. I need to tell the system that I'm going to be using the geolocator because it's sensitive. I don't want my app sniffing on people. Obviously a weather app, it's kind of obvious that you want to use the location, but if it was an app involving juggling penguins or something, you probably wouldn't want that necessarily sniffing your location. So what I need to do now is the debugger has actually thrown me an exception, and Visual Studio has interpreted that and said, oh, well, I know what this exception is. It means you don't have the location capability marked in your app. And it's even given me a link that I can click on that will take me to the app manifest where I just was and add the location for me. So now when I run it, I should get the location. Well, not quite yet. So the system now knows that I need my geolocation, but I still need to ask the user. So the system is asking the user on my behalf, is it really all right to use the location? And I can say yes, and we're in Texas.
That's what greeted us this morning. Hey, actually, looking at the weather, I wouldn't mind being in Texas right now.
It looks good. It looks good.
It's actually, I think it's the first time we've seen all sunny days.
Yeah, and of course our live tile's updated to also tell us that we're in Texas. Great. Okay. Are we done?
Well, since we're not in Texas, we kind of like to know what the weather is here in Seattle.
Right. So a great way to implement a search functionality in your app is to implement a search contract so that the user can use the search charm. And we'll take this opportunity to implement a search feature in our app so that we can search for locations from which to display the weather. Okay, I need to go back to that package manifest once again and need to declare to the system. You'll recall from Steve's demo earlier on today that in the search charm, not only do I have apps and files and apps on the system, but I can also delegate my search to various other applications that are on the system. All of these apps had declared to Windows that they support search, and they should be put in this list as an option to the user when the app's installed. So I need to do that same thing. So I go to the Declarations tab within the Manifest Designer, select Search, and click Add. So now the system knows that I should be presented in that list. But obviously I need to write the code to respond to the search request from the user. So let me go ahead and do that.
And these are what we call contracts. So you'll hear about them a lot this week. There's share, there's search, and you program them all pretty much the same way. There's some global object that you deal with, and then from there you register for events. And when it's time for the system to talk to you, it'll trigger the event, and then your event handler can go ahead and do the logic. So here in this particular case, we want to be able to search for the weather, and so when the system pings us, we tell it, okay, great, we can go get the weather.
Great. So I'm wanting to show the weather based on the textual query that the user typed in. But the code that I have to go and talk to my web service is using the geolocation coordinates. So I need to change that. Now, because it's JavaScript, it's very accommodating as far as types are concerned. But sometimes I need to ask. So I'm going to ask, did I get past a string? No, too many.
That's in the next release. They'll have really equals. All right, so you're just going to pass this to your service, and hopefully your service already knows how to interpret that.
I hope so too.
By the way, that dialog will normally only come up once. Since we've edited the manifest, Visual Studio has told Windows to get amnesia on what the app has and has restarted it. There we go.
There we are.
That's what we've been seeing all week.
Okay, let's try somewhere else. Let's see how our friends over in New York are doing. Okay, not as bad as it was.
No, definitely not as bad as it was. Right. Well, can you check Tokyo for me?
Sure.
Right after this, I'm leaving for Tokyo. So
that's all right for some. I'm going to Building 41.
Yes. 41 Tokyo is a toss-up.
Great.
Awesome. So the weather there looks halfway decent. Yay. All right.
Do some more talking.
I get to talk now? Yay.
No, I'll do some talking.
You want me to? You do some talking. I'll do some talking. All right. So now that we've gone over sort of the high level of building the store app, I want to drill down a little bit and help you understand what the system's doing under the covers when your app's running. I mentioned before about this concept of users having confidence. And for Windows 8, we were really focused on making sure users had confidence in their apps so that they would install your apps. The funny part about it, though, is confidence is actually a feeling. It's really not. It's very hard to write a spec on feelings, and we as engineers are actually really bad at dealing with feelings. And so we spent an awful lot of time trying to figure out what are the engineering things we had to do so that users would have confidence. And the first thing we did was we realized that we couldn't just let your app run like it always does. I mean, today, when your app's running, it can do anything that the user can do. It means it can get at all of its data and everything else. We really didn't want that. So we built something called the app container. And the app container is something that it's a container that your app runs inside of, and we use it to make sure that you only get access to the resources that have been granted to you. Well, how do you get at resources? Obviously, you're calling the WinRT APIs, just like Kieran did to get the geolocation class. And so most of the calls that you make in WinRT are just direct system calls. It's just like Win32. You make a call, it goes to the operating system, it comes back, and you're done. Some of the calls are sensitive, like the user's location. And those kind of calls are what we call brokered API calls. When you use that object, it's really under the covers making a call to a privileged system service called the runtime broker. And that runtime broker now is responsible for making sure that you only get access to the things that you've been allowed access to. So in this particular case, it says, okay, you're looking for the location. It checks the manifest. The first time it checked it, it wasn't in the manifest, and so it failed. And then the next time it ran, it said, okay, it's in the manifest, but has the user granted you access yet? And this is something we allow the users to choose, both initially, and they can also change their mind later by going into the settings charm, and then they can go in and see if they granted you location before, they can revoke access, or if they said no the first time and now they want to give you access, they can. So I saw that while I was talking, you were typing furiously away. Give me one more second to talk first. Still looking at your code? There we go. One other thing about confidence is not just resource access, but it's also things like battery. So if users had to say, every time I install an app, I lose a bit of battery, then would you be really confident and install lots of apps? No. And we know there are operating systems out there that are just like that. Every time you install an app, your battery kind of goes down a little bit, and at a certain point you have to decide which apps you want to install to get your battery life back. And we didn't want that to happen. And so what we did was we built a system where when the user's not using your app doesn't get to run. It doesn't get to eat up the battery, which also means it doesn't get to hurt the performance of the foreground app. So if I'm playing Halo, I don't want your app sitting there churning away and doing calculations because I bought this system and right now I've decided to play Halo. And so, as a developer, you're going to have to basically do a couple of things to make sure that in cases where we need to do more than suspend your app, like in the case of we're now getting low on memory, we sometimes have to terminate your app. You need to do the things at suspension time or you need to save the things so that you can remember where you were, so when the user comes back, they get that seamless experience as if your app had never been terminated. And so, now Kieran. So while I was talking, Kieran did all the work that he would need to do in order to make his app have memory. So what did you do?
Oh, so much work. So the suspension notification appears in my JavaScript application. There are slightly different mechanisms for C# and C++ applications, but in JavaScript, WinJS surfaces that to me as an event called onCheckpoint. And all I've done here is populated an element in a property bag that, again, WinJS is providing for me, and say, well, I want you to store away the last query that the user did via the search charm. So that is then persisted to disk so that next time the application comes back, it can see it. Then during the launch, and all of this is part of the Visual Studio template, then during the launch, I get a slightly different code path when I'm being suspended back from being in a sleep state. And I then recover the last query, and then if I happen to have a last query, I shall go ahead and show that. Otherwise, I shall use the geolocation APIs. So let me look at that in the debugger so that you can see the state transitions. Let me do a search, Tokyo. Now, the Visual Studio debugger has a mechanism in it to deliberately trigger these suspension states, and it's right here on the process toolbar. So if I drop that down, I can see that I've got suspend and shut down, which immediately moves from suspend, once it's finished that, through to the low memory terminate the app event. So I'm just going to hit that, and you can see that I'm stopped in the debugger on the event handler that's going to persist my last query, which has Tokyo in it, and then my app quits. Now, if I start the app in the debugger again, you can see that it's followed a slightly different code path to the normal startup, and it's giving me the opportunity to recover that information. There it is, Tokyo. And now it'll use the show weather on Tokyo path. And if I switch back, there's Tokyo, not our geolocation in Texas.
That's it?
That's it.
Excellent. I will now...
Now you have a go, Monkey Man.
I hate giving that thing up. I like to...
Okay, so we saw an application written in JavaScript. There we go. We saw an application written in JavaScript. It started with very, very standard JavaScript and HTML code with a bit of CSS. Then we gave it the character, how I would want it to appear in the store if I was to submit it, with a tile that had been beautifully crafted by a designer, a splash screen that fitted in the same color scheme and character as the internals of the application, giving that user the constant flow of the application's identity from store all the way through to the running app. And then to meet those all-important user expectations now, a live tile for the app, being driven by, in this case, an Azure Web Service, implementation of the search charm. Obviously, there's all-important capabilities to give access to things like the geolocation API and to declare the fact that I'm supporting the search contract. And then PLM, to make sure that my app does have a memory, that the user can return to my app even after weeks of being away, and it's exactly back where they left it, even though it's actually been quit and rerun again. Now there's one more step along this chain. So we now have an app that works really well with Windows. The Windows 8 gives you the ability to have applications that work well with other apps. So you get this amplification effect of apps helping other apps to be even better. And John, I think this is your opportunity.
To show that I actually know how to code? Excellent. Now, I'm not sure I actually do know how, but we'll see. So what I'm going to do here is we're just going to start by creating a blank app. And since my favorite programming language is C#, I'm going to go with that. So Visual Studio creates me just kind of your standard blank template. I'm going to go into the XAML designer and just create a couple of simple things. I'll create a button for me to click so that I can pick a file, and then I'll display that file to the screen to show that we were actually able to pick it.
So we're going to pick a picture or something?
Yeah, we'll pick a picture.
Great. Okay. So XAML IntelliSense, obviously from Visual Studio, is helping us out here. So the Windows 8 provides a number of facilities built in to help our app communicate with other apps that are running. The one that we're going to be using here is the File Open Picker. And the File Open Picker is, you can trace its origin back to the common file dialogues of Win32 that along the lines that John mentioned earlier. But the File Open Picker has a number of other features that are available to it, as we'll see in a second. But it gives you the ability to pick from places other than just a file system. But as far as the code is concerned, we just have to instantiate the file picker, and then we need to tell the file picker the file types that we're interested in. And in this instance, since we want a picture, we'll just have a JPEG. Obviously, there are more types than that, but we'll just go for the JPEG for now. Now, just as many of the Windows runtime APIs, they were designed to support your application having this fast and fluid user interface, that while you're doing expensive operations like talking to the network, talking to the filing system, that the system can continue running while your code is while it is off doing those kinds of operations for you. And I see, John, that you've used C#'s rather glorious async and await keywords.
One of my favorite features of any of the languages.
Yeah, it's great because it allows you to continue to write linear code. So the code is completely as you would as you would write it if you were being completely linear with completely synchronous APIs, but it's asynchronous, and it does the right thing, yielding back to the user interface to make sure that touch responses and animations and all those kinds of things continue operating. It's also a great way to get some degree of parallelism as well, because obviously you can carry on doing work while the code is off, going and getting perhaps something back from the network or anything like that. So once we've got the stream back from the file open picker, we'll create a new bitmap image, assign the stream that we got back from it, and then assign that resultant image up into the XAML image that we just created.
Right, and it compiled, so obviously it's just going to work.
Oh, it's going to work.
Hey, I've got a button. Look at me.
And there's the file system, but also have a list of apps. And SkyDrive surfaces itself as an app.
And so now I can go into the SkyDrive, and actually, this is Kieran's SkyDrive, so I can go start poking around in his pictures and see what we got here. And we have something that looks quite adorable.
It's the 1984 BBC Master 128.
Oh my God.
And Holly's pretty nice too.
Poor girl. So, all right, so we have an image, but that's not particularly interesting. That took like 10 seconds to type.
Great.
So let's do something real.
You want something a little harder?
I want something a little hard. I'm up to the challenge.
Okay. Let's manipulate that image in some interesting way that's hard, and then share it back out again up to SkyDrive in its edited state.
Okay. So now we're talking about editing pixels in an image, and unfortunately that's something that's a little more challenging than typing a few lines of code. And so, like all good developers, when I want to start using some APIs, I go to the samples. And we encourage you very much, always, when you're trying to figure out something new, like you want to start using geolocation, go get the geolocation sample. It'll have all the information there for you. Normally, to get the samples, you'd go out on the website and search for them or whatever, but Visual Studio has this really cool new feature where I can just say new project, and one of the choices I have is online. And if I drill in online, they'll have templates, and then they'll have samples. And so here, we want to use some Direct2D and Wik technologies, because those are the technologies on Windows for manipulating images. So I can just look for Direct2D, Wik, 2K, 2D.
Direct2K?
Direct2K, yes. Wik. And if I search, the first hit is a Direct2D and Wik image editor.
As luck would have it.
As luck would have it. We have not practiced this, I swear.
Written by Joanne Tuff. Yes. She sounds familiar.
Yes. And so now when I go and get that sample, Visual Studio is going to create me a project, pull all the information from it, create a directory, do everything. And obviously the first thing I'm going to want to do when I get a sample is figure out what it does.
Great.
So I'm going to...
Looks like it's a single solution, 2 projects in it. One of them looks to be in C++, the other one in C#. C# XAML. I'm guessing there'll be a project-to-project reference from one to the other.
Yeah, and so it looks like it set the wrong thing as a startup project, so I'll go ahead and change that. And now if I run it, here we have a sample. Again, it lets you choose a photo. I'll go back to SkyDrive, and we'll go pick another picture. And it looks like it's put some tiny text on there and a square. Okay, so it's definitely edited the image and redisplayed it. That's not particularly interesting.
Can we edit it in more interesting ways?
We probably could. Well, first of all, that tile looked a little bit small. So let's go and see what the code did. In this particular sample, it looks like they have created something called a Wik image, which for those of you who aren't familiar with Wik, Wik is the technology that we have mostly for reading and writing different image formats, and also lets you do a small amount of manipulation to it. And then there's also an image editor here, which looks like gives you some more advanced capabilities. And the way you do advanced image manipulation in Windows is you use Direct2D. So, first of all, let's just go in, and that SolidRect wasn't really doing anything for us.
The font was a bit small too, wasn't it?
The font was a bit small. We'll call it Daddy's Girl. And My Child, yes. And we'll just make it a bit bigger. And so now if I do it again, not surprising, same thing, you'll see we go and pick it. Windows remembers that I was already on SkyDrive, so I don't have to go back and keep doing it. I can go into public, pick the picture, and there you go. So, all right, that was pretty interesting. Not really?
Not enough.
Not really.
Not enough.
So what do you say we go and actually look at some Direct2D and Wik code?
There we go.
All right, that's the kind of code we want to write today. So if I go in and look at what this sample has, it looks like just a basic wrapper for a Wick image. You hand it a stream, it can do some basic operations, and can get you back out a random access stream for it. Okay, there's also this image editor thing in here, and when I look in here, I start to see something that looks a lot more Direct2D. It's got a begin draw, an end draw, it's dealing with DPI, and then it has these functions in here like we just used, like draw text. So what do you say we add another function to do something?
Draw an image.
Okay.
Draw an image on the image.
So we'll draw an image on the image. So let's say if we wanted to create collages or something like that, I'll create a function that draws images. And so since we already have a wrapper for Wick, I don't need to deal with the low-level Wick APIs right now, especially given we have like 5 minutes. All right, so I'll go ahead. If you notice one thing in here, what's that, Kieran?
It's a hat. Very technical term.
Why is the technical term hat in there?
So the hat is an indication that this is a CX reference. So CX is the language syntax that's moving forward from C++ CLI to Windows 8. It's 100% native code that's generated from the C++ CX, but it makes dealing with things like Windows Runtime and the XAML-based UI stack so much more straightforward, very highly object-oriented, very asynchronous, but still native code. So the memory and object lifetime is completely controlled for you by CX. Whereas with the old COM, the classic COM that we know and love, needs some assistance with its lifetime management. And you can see here that John is using a COM pointer. And the COM pointer is a smart pointer. And you can think of CX effectively embedding the smart pointer capability in line with your code so that you don't have to worry about it controlled by the hat, the reference. But for classic COM code, we need to wrap those in a COM pointer. Now the Wick image APIs are COM-based, and in order to use CX and Wick together, we're just getting the same kind of automatic lifetime management that you get from CX, but using those CCOM pointers instead. Now we've got a number of things that we need to do, because Direct2D is designed for blitting to a graphics card as fast as it possibly can, whereas Wick is really designed for image manipulation. So the internal in-memory representation of those two bitmap images is different. So what we first need to do is, the Wick image, we need to say, okay Wick, please give me an image that is compatible with D2D. And then we actually need to hand that onto D2D so that we can start rendering on top of it. The render target is effectively where we've been doing all of the drawing and manipulation. So what we've done here is we've created a bitmap from the Wick bitmap, so now we have a D2D surface on which to draw on, and then we've just drawn the D2D bitmap that we got back from that call.
Great. So now we just need to call it.
So now we should have a new public API on this D2D image lib component that should allow us to draw images on images. So we'll start with the stream that we already had.
Yeah, we'll just do that. We could go and pick a new one, but let's not do that. We don't have time. Right, and so let's go ahead and we'll rotate the image. We'll do it vertically, which is a little more fun. And let's go ahead and scale it. And we can scale it by some scale factor, which is a float, so we'll make it a little bit smaller. Pretty simple. And now we just need to go ahead and draw that. And so if we go in and go back to our editor class, we'll now see that in IntelliSense, that function that I just built is now there, and I can call it directly from my C# code.
And that's because of that project-to-project reference between the two projects. It's automatically pulling it up. That's great.
And did I do it correctly? Probably. I hope so.
Okay.
All right, so now let's go in and see. So if I go back and pick the image again, and this time, if I look, I've actually edited the image, I did some manipulations on it, and then I composed two different images together, wrote some text over it. All right, so I've proven that I can code. Am I done?
Almost.
Oh, wait, there's more.
Got to share it.
Oh, that's right. I've got to share it. I forgot about that. All right. So now I want to actually share this image with the world. And so to do that, I just need to go and register to to handle the share contact.
So the data transfer manager, which is the object in the application model that handles transferring of data from one application to another, is instantiated in a very, very similar way that you saw in JavaScript with the search charm. Because we're implementing the share contract here, what we need to do is we get hold of the data transfer manager, and the data transfer manager has got an event handler on it that will get fired when the user invokes the share charm. So we're just attaching a method handler to that. And then what we need to do is we need to go ahead and prepare the data packet that will actually get sent out there. And the data packet that we can send through the data transfer manager is actually pretty rich. We can put quite a lot of information in there. But there's a few things that we need at a minimum. We need, obviously from a defensive programming point of view, we need, if the user has decided to share at a point that's inappropriate for my app to be shared, if I haven't actually opened an image yet, for example, I certainly wouldn't want the app to just crash. But I also want to help the user understand that I do support sharing, just not right now. So if the share stream, which is what we're actually going to be sharing very shortly, hasn't been populated yet, then we just send a nice message to the user saying, you haven't chosen an image yet. Let's please go ahead and do that. So the data packet, there's a couple of things that, just one thing that we need to do at a minimum. We need to populate the title so that the share flyout has got good information in it. And then on that data packet, we can then call set bitmap and pass it a stream. Now, interestingly enough, we've actually received a stream from the image picker. We then converted that stream to a bitmap. Direct2D edited it, and as luck would have it, on the sample API, there's a call to get the stream back. And we're not quite done yet because that returns to me an iRandom access stream. And I can't pass an interface to an iRandom access stream across into the data transfer manager. What I need is a reference to that stream. And this is so that Windows can optimize the memory utilization and memory usage across that process boundary and through that broker that John mentioned earlier. Now it looks like...
I think I'm done.
You're done. Let's see.
Let's hope. So now if I pick the picture, I go in and look, and I see that when I hit share, it comes up. I can choose something. I can share to SkyDrive. You had your stuff under public, I believe, so I'll go ahead and re-upload it to public. It added it, and now if I actually go out and look in your SkyDrive, I should see that there's a new photo there, and it's the one that we just edited.
Great. All right. I think we are done.
Are we done?
Okay, so it all started with some code. In both of the app demos, it really just started with a rudimentary idea and building up through giving your app some character, giving it a consistent look and feel, living up to the user expectations of everything being alive, implementing the important contracts, giving a live tile search contract, making sure you declare your statement of intent to the user through capabilities, giving your app a memory through PLM, and then finally making your app not only work better with other applications, but also the ability for one language technology to use another language technology. So giving you the ability to really make the best use of whichever programming language you choose. So for example, obviously Direct2D, C++ is the most natural language to be doing that in. Ladies and gentlemen, thank you very much for listening to us today.